Welcome to Day 4, Lesson 4 of Math 135. Today we're going to look at piecewise-defined functions, okay? And I decided that what we might want to do to start out with is to look at a real-life application, because of course, lots of times you guys are too nice to say, when are we ever going to use this? But that's a legitimate question. Okay, so last semester when I was working on this, we brought this down in my college algebra class and we said, all right, you got a cell phone plan going here and it's got 450 anytime minutes, 5,000 night and weekend minutes, and if you go beyond your minutes, it's 45 cents a minute. There is a one-time activation fee, but we don't care about that guy. We're going to totally ignore him. We're going to assume you paid him in the first month. And it costs $39.99. Essentially, we can say 40 bucks. So 40 bucks is your monthly fee. And then the only other way that you're going to have to pay is if you go above your minutes. Now, to make this a little bit simpler, because this is, just kind of our first try at this, so we don't want to make it too tough, we're going to just assume that you're not going over your night and weekend minutes. 5,000 is a lot. Do you really need to talk that much? So, what we're going to do is assume that maybe you go over that 450 anytime minutes. And so I already said, well, in algebra we love our x's, so we're going to let x be the number of anytime minutes that occur not on a night or weekend. So these are the ones that you're limited to 450. All right? And we're going to want to write a function for how much it's going to cost you. Now, you know what? That's actually kind of a tough thing to just suddenly spit out that equation. And I don't expect that you're going to do that. So let's think about it. In fact, I often encourage you, when you're having trouble writing these equations, let's turn on our common sense and just play with the problem for a minute. Okay? Essentially, we're going to say it's $40 plus 45 cents per minute past 450 minutes. And this is for a month. So this is what we're dealing with. So it's too hard to just spit out an equation with x. How about if we think about some numbers? Like, what if you have 300 minutes? 300 anytime minutes, because we don't care about those night and weekend. If it's 300 anytime minutes, what are you paying? You're paying 40 bucks. Okay. Well, what if you had 350 minutes? 350 minutes anytime, you're paying how much? 40 bucks, right? Yeah, I know. I'm not too bright, but we're getting there. Well, what if we've got 450 minutes? At 450 minutes, they're going to let us do 450, right? So we're paying 40 bucks. Okay. Well, what if it's 500 minutes? We're going to pay 40 plus, right? Okay, so we're going to pay 40 bucks. That's just the flat monthly fee. Yeah, I know it's $39.99, but who wants to deal with a penny? All right, so 40 bucks plus, we have to pay for extra minutes, right? How many extra minutes do we have? I'm going to take 500 and I'm going to subtract off that 450. So I got 50 extra minutes and I'm going to multiply that times 45 cents, right? So 50 times 45 cents, whatever that happens to be. I don't want to deal with the numbers at the moment. Because my only concern is, how do I get this? So what if you had 600 minutes? How would you figure that out? Well, you have to pay the basic $40. And then you're going to have, how many extra? 150, yeah? And we get the 150 by taking the number of minutes we actually used and subtract off the 450 that are for the basic fee. And we take that times 45 cents, right? Okay. So we kind of have the idea of what's going on here. You know what's kind of interesting about this? If you look really closely, do you see that there's kind of two ways to figure this problem out? Because up until you hit the 450, there's just a flat fee. It's just a straight $40. And then suddenly the problem changes when we go past 450. That means that we should write what's called a piecewise function. Now, what we mean by piecewise is this. You're going to write a function, and it can have as many pieces as you like, but we're going to start with just two. We're going to have one piece for this first situation, okay? Well, that means that my beginning cost is just a flat $40, okay? But you've got to say, well, when is it $40? Well, it's $40 as long as my minutes, and we decided our minutes was going to be the x in this problem, as long as my minutes are 450 or less. So I can say for x less than or equal to 450. Now, once I get above 450, then the problem becomes a little bit more complicated. So let's think about how it was that we were doing this. You have the 40, but there's an additional charge as well. And how do we find this number that we're multiplying by the 45 cents? Well, that seems to be the number of minutes that we are past 450. Okay, so let's actually run one more in my little chart here. What if we go x minutes? And what I want you to do is just mimic what we were doing right here. We still have the $40 plus, now how do we get the 150? It's essentially the number of minutes minus the amount I'm allowed. So if I have x minutes, I have to write that x minus 450. And what do I do with that? Multiply it by 45 cents. Okay, so essentially there's the second part of my equation. So I'm going to say it's 40 plus x minus 450. Now, I'm almost running out of room, but we'll fit it in there. I don't want to put the cent sign in here, and since this is in dollars, I really need to make this 0.45. Okay? Now, once you get it done, it doesn't hurt to take just a second and look at this again and see if this makes sense. We're saying that if you go less than 450 minutes or exactly 450 minutes, you're going to pay $40. But there's a second option for figuring out your answer here. If you go more than 450 minutes, you've got to start with your $40 and then figure out how many minutes beyond 450 you used, and they're charged at 45 cents a piece. Does that make sense? Well, you know we love to graph things in algebra, so let's graph this guy. Now, to graph this, I did just put a basic graph here, just to give myself a grid to work with, and I decided that we'd talk about what scale to put on here. You can see that I've got to use some pretty big X numbers, all right, because 450 is kind of where this thing is breaking, so maybe I could go by hundreds. So this is 100, 200, 300, okay. And then for the cost, better not have to go by hundreds, or your parent or spouse or just yourself are going to be really angry about this bill. So let's go by tens. 10, 20, 30, 40, 50, 60. Okay. So let's see here, let's plot a few points, because remember, if you get into a tough spot, a good backup plan is to kind of use the table of values idea. Let's see here, if I don't use any minutes, how much does it cost me? Because remember, down here along my x-axis, this is minutes, and specifically the anytime minutes. And then this is going to be the cost, my monthly bill. Okay? So if I don't use any minutes at all, are they still going to charge me? Well, you bet they are. It'll be $40. And what if I use 100 minutes? It's $40. And it's $40. It stays at $40 until when? $450. Okay, so right about here. And by the way, right at $450, it still is costing us $40. So we would draw a line, in this case it's a horizontal line, and we'd have a nice closed circle there on the end because that endpoint is included. Okay, now let's see what it's going to cost beyond there. Okay, hey, do you realize that essentially it's just going to climb from here? At 500, oh, now I might have to actually do a little bit of arithmetic on that. Let's see here, 50 times 45 cents, looks like that's going to be about, what, $22.50? Wow, 62 bucks. So it's going to jump up there to about 62 bucks. And by the way, do you realize that this guy's going to be a linear equation? And once you get one of those, you know that cost is just going to continue in that same way. So by the way, what did we discover with this particular situation? One equation, one simple equation by itself was not going to be sufficient for this particular situation because there were two conditions. And there's a breaking point. You're going to have to watch for breaking points. My breaking point in this case is that 450 minutes, right? Okay. All right. Well, let's go on. When you see a piecewise-defined function, a lot of times we use this big brace. And as I said, you can have as many parts as you want. But let's take a look at this kind of complicated function. Here's my function name. He's f of x. And it can't be a little simple function. No, no, no. We've got three different pieces to this function, or three different parts. And with each of these pieces, you will have a condition set as to when you go to that particular part. And you know, once you get used to this notation, it's actually very sensible. Your function is going to be negative 2x as long as x is less than negative 1. So like if your x value was negative 5 or negative 10, you would use this particular piece of the function. Now, if x is falling between negative 1 and 1, and you do watch where you have the equals and where you don't have the equals, then what I'm supposed to do to get my answer is I'm supposed to square it. Okay? And then lastly, for anything 1 or bigger, the answer is just negative 2. Okay? So essentially, that's what this particular notation is saying. It's saying your function is not going to be just this simple little bitty one-part function. We're going to give it to you in pieces. But we're going to tell you when to use each piece. So watch for that information very carefully. Okay? Well, let's graph this. Now this may not be beautiful, but what I decided to do was, if you take a look here at my function, I've got a straight line, y equal negative 2x. So I decided, you know what, it might be easier for me if I look at that whole thing. So here is y equals negative 2x. Looks like a straight line, goes through the origin, slope of -2, right? Second piece is x squared, y equals x squared. So here's the graph of the parabola. You know our old buddy goes through 0, 0. Yeah. Okay? And then the third piece is just y equals -2. Now do you remember that if it's y equals a number, he's horizontal line going through -2. Now here's what's so cool about this. It's actually extremely easy to graph your piecewise functions if you just organize yourself. What I want to do is I want to take a piece of that, and I want to take a piece of that, and I want to take a piece of that, and put them together to make one big graph. Well, how do I know where to cut it, what pieces I want? Well, go back here. This tells you exactly where you want to cut it. So for this line, y equals -2x, I want it left of -1. Now remember, the x values are less than -1. So I come over here and I say, all right, well, I want this part that's less than -1. It's a part of that line, okay? And by the way, sometimes students get confused on the x coordinate or the y coordinate. In this particular case, you need the x coordinates, like right here. You need all those x coordinates to be less than -1. So essentially, think of your x-axis. You're going to cut it there, and you're only going to take that side. Okay? Well, oops, let's go back here. For my parabola, I want -1 up to 1. So I go to here and I want from -1 to 1 for my x's. So I want this piece right here. Isn't that pretty sweet? Hey, and by the way, technically you've got to pay attention to where you have end points. So if I go back here, this guy is technically an open circle because we don't include the -1, but here we'd have a closed circle at -1. So I would have an open circle here, and I'd have a closed circle, and this guy was an open. It's a feature that I couldn't really put on my pieces when I cut them. And then my last graph, this horizontal line, where do I want him? I want him where x is 1m bigger. So you go to the graph and you say, well, where is x1? It's right here that x is going to be 1. And I want 1m bigger, so I want this whole chunk, and I slide him over. And I did want the end point there. Boom. There's my piecewise. Isn't that cool? Hey, by the way, if you really struggle with the concept of doing your piecewise, you could do essentially this same thing. I know you don't have a smart board. Believe me, it's probably easier. Get yourself some graph paper, make each of these graphs, and then physically cut them and tape them together to see what this would look like all together. All right? It's a good idea if you're struggling with the ideas. Okay, now here's what I'd like to do is graph this particular piecewise function, g, and then we're going to have to find some function values. Now you might wonder, why does she have two graphs there? Well, I decided that what I would do is put that little graph on the side just kind of as a workspace. You know, it's kind of like scrap paper off on the side. Because what you might want to do is think, what does this whole graph look like? Because sometimes we complicate this process. You know what y equals x plus 4 looks like. If I want to graph y equals x plus 4, you know that's a straight line. You know he has a y-intercept of positive 4. 1, 2, 3, 4. You know he has a slope of 1. And so you know very well, there's your graph. Okay? Now, I need just a piece of that graph. Okay, what piece do I need? You know, sometimes we go ahead and put that piece in first. Notice where I'm cutting this. I'm cutting this where x is 0. Well, along the x-axis, where is x 0? It's right here. So give yourself a whole vertical line. And I don't care, you could dot it, or I'm just making it wiggly because it's not part of my graph. It's just a little helper here. So essentially, I need to cut this right here. And if you'd like, you do what's going to work well for you. You could erase this part of the graph. And you could say, I only want this part of the graph. Notice I do want where it equals 0, so I can go 1, 2, 3, 4. I want that point, and I'm headed down with a slope of 1. That's the piece for this top part. Hey, by the way, you do want to watch carefully. A lot of times we'll have the left part on top and the right part here. Don't automatically assume that, okay? Read real carefully what your conditions are. Now for my second piece of the graph, I have y is equal to negative x plus 2. Well, if I come over here to my workspace, y equals negative x plus 2. I know he's a straight line. He goes through negative 2, or positive 2, I'm sorry. He has a slope of negative 1. So that blue line would be y equals negative x plus 2. And you've been graphing that since Algebra 1. You're good with that. What piece of that do I want? I want it where x is greater than 0. So think along your x-axis. Where is x greater than 0? It would be from your origin to the right. Now, do I include the endpoint on this guy? No, the equals isn't there. How do you show that? Well, you exaggerate. You put an open circle, and then we show our negative 1 slope going down. Yeah? That isn't so bad, is it? And you see a line. I've got a part of a line. A line. I've got a part of a line. That's exactly what I was supposed to have. Now, I would like to also find some function values here. So I'll clear off this space a little bit. G of negative 3. Now, of course, we talked about this in a previous lesson about how you want to go looking for the g function. Well, here's g. And g of negative 3. If I'm going to put a negative 3 in here, that means, of course, that x, for the moment, is negative 3. The first thing you have to do is decide which piece do I want. Okay? Well, is negative 3 less than or equal to 0, or is negative 3 greater than 0? You know the obvious. It falls here. So you're going to put it into this piece. And you would say g of negative 3 is negative 3 plus 4. It'll be 1. Now, by the way, that means that the point negative 3, comma, positive 1 should be on this particular graph. And is it? Well, negative 3, positive 1. There we are. Looks good. Okay? Well, let's try g of 0. Now, for g of 0, momentarily, x is 0. So the question is, do I put it into the top piece or the bottom piece? Well, be careful on these boundaries, and 0 is my boundary here. Make sure that you get the one that includes the equality. So we would be using this top one, so it would be 0 plus 4, which is 4. Now that means that the point 0, 4 should be on this function. And is it? Well, you know, this is really kind of interesting because if you go to x is 0, you see this open circle at 2, and you might think, oh, I've got 2 points there. I failed the vertical line test. No, that's the whole point of having that open circle, because we are saying you go up to that point as close as you could possibly get, but you don't get to that point. So right here, 0, 4, that's the guy we included. Okay? And lastly, G of 4. For G of 4, which piece am I going to use? Well, obviously, 4 is greater than 0, so I must use this bottom piece. I'd have negative 4 plus 2. I would have negative 2. So the point negative 4, comma, negative 2 should be on the graph. And at, oh, how about if I put that as positive 4? Oh, I know why. It was a negative 4 there, sorry. But then I got crazy over here. It's a positive 4 here. So I go to positive 4, 1, 2, 3, 4, negative 2, and there we be. Okay? Well, now I've got a 3-parter and apparently an extra plus sign for some reason. You can just ignore this plus sign. I have no idea what I was thinking at the moment. Plus 0. We're good. So we've got Q of t is equal to, and we've got 3 different parts on this guy. You know, that's kind of like that example, and luckily then we got to cut it. Well, this time I'm not going to cut it. I need to graph this guy. So let's start. What will y equal t squared look like? And remember, it's kind of nice to have this extra little part here. Y equals t squared is going to be my favorite little parabola guy. Right? Now, where am I supposed to cut him? Look right here. For t less than negative 1. Okay? And apparently, we've got a t-axis and a q-axis. Okay? So t less than negative 1, that would be from here left. Okay? So I say, all right, apparently I'm going to cut it down here right along this negative 1. And I would have the point negative 1, 1. But notice I don't have the equals there, so I put an open circle and I say go up that part of a parabola. Essentially, realize that what I would be doing is cutting that little piece and sliding him over here. That's the part that I want. Now for the middle part, and you might say, well, where is the middle part? The middle part is going from negative 1 up to 2. So where x is negative 1 up to where x is 2. Here's my middle piece. And in that middle piece, I want the graph t plus 1. What does y equal t plus 1 look like? Y equals t plus 1. That's just a straight line, right? He's got vertical intercept of 1. He's got a slope of 1, so he looks like this. And then I want to just cut. I want from here over to here. I want just this part. Okay. Hey, you know what? A very good idea is this. To actually nail down your end points, take this negative 1 and put it in. If you put in the negative 1, you get 0. That's exactly the point that I have right there. And we can't actually have that. It's a closed circle. Now put the 2 in. I know the purists in the room are going to say, you can't. I know. I'm going to put an open circle there. But I want to know where to put my open circle. So take that 2, put him in. 2 plus 1 is 3. 1, 2, 3. See? 2, 3. The line goes right through that point. But that's the end of it. So there's that line in the center. My point is this, as you know what the whole graph looks like, and then you're trying to figure out where your little piece of that line happens to be, consider putting these guys in to get your endpoints. It can be helpful to you. And then the last one, we have y equals negative t. Y equals negative t. You know what that guy looks like? Yeah. He's running down here with a slope of -1. He had a y-intercept of 0. And then the only thing is, well, what piece of him do I want? Well, I want where t is greater than 2, so it is from here over. So it's right there, boom, and to the right. Again, if you want to get the end point, put the 2 in, and you get -2 headed down. Okay? Lovely graph, kind of like those colors. All right? Now, let's go ahead and check some function values here. Okay? First off, q of -2. So, if I want to get q of -2, that means my t value, my input value, is -2. So I first determine which of these 3 intervals my -2 is going to fall into. And he's going to be in this guy. He's going to be less than -1. So I square the -2. That means that I have the point -2, 4. And -2, 4, well, I hit it pretty decently. Okay, q of 0. Now for q of 0, again, the first thing you have to do in the case of a piecewise function, they're not nearly as scary as you might think. For this piecewise function, I want to figure out, well, which piece do I want? Well, he's not less than -1. He is greater than -1, and he's less than 2, so this is the piece that I want. So what do I do with him? 0 plus 1, I get out a 1. Well, let's check that out. 0, 1, looks good. Well, let's try 2. Q of 2. That didn't work so well, did it? All right, so I go to the first part. Is 2 less than -1? No. Is 2 between -1 and, well, he's not less than 2. Let me erase that just to make sure that I don't have an equal sign. I don't. Okay, so he's not there. Well, he's not there either. How can that be? Well, you know, if you look at the graph at 2, up here I've got an open circle, down here I have an open circle. Apparently I have nothing for when t is 2. You know what that means? Think back to what we talked about with functions. 2's not in the domain. You know, 2's kind of like the penny you can't put in the pop machine. It's not going to work. So I would just have to say it's undefined. And if I wanted to, I could expound upon that and say, hey, 2 is not in the domain of q. So I can't give you any function value. It's not possible. It doesn't exist there. Okay, we can do that. Now, how about q of 4? Well, let's see here. 4 is not there. 4 is bigger than 2. So we go to the third piece. And all we need to do there is simply change the sign. So we should have 4, -4 on our graph. And sure enough, 1, 2, 3, 4. 1, 2, 3, 4. Boom. There we go. That wasn't so bad. Now, a good idea sometimes is to start out by putting your breaks in on this graph. That can be real handy as you start the graphing process. Another thing that I've suggested is to go ahead and have this extra little workspace somewhere off on the side that you can play with what these functions are going to look like, you know, and then figure out where am I going to cut it, okay? Well, this particular guy I brought up just to continue to answer the question that we started this lesson with. Why are we doing this? This is from www.irs.gov. This is official schedule for computing your taxes coming from the Internal Revenue Service of the United States of America. And guess what? Let's take a look at this. You've always heard people talk about being in higher tax brackets. Well, if you really had no idea what they were talking about, here's a chance to get a peek. All right? Now, this was, of course, in the 2009 booklet, the book for taxes for 2009, and it's showing if your income was between $0 and $8,350, you're paying 10%, and by the way, that's taxable income after all your deductions and everything are taken off. You're going to pay 10%, okay, of the amount over $0. So, if your taxable income after those personal exemptions and deductions is $0 to $8,350, you're paying 10% of your taxable income in taxes to the federal government. Now, once you jump up over the $8,350, then until you hit $33,950, you're in the 15% bracket. Now, by the way, what's interesting and also kind of complicated is you're only going to pay 10% on that lower part. You pay 15% only on the part that's above $8,350. You know what? Do you see that this is a piecewise-defined function? And in fact, even though they didn't use inequalities to show that to us, I think they were afraid of freaking us out in case they didn't think we were already freaked out. But anyhow, they're showing you essentially right here the intervals for each of these pieces. And so for the lower part of your income, you're paying 10%. Then once your taxable income gets up above that $8,350, you're going to pay 15% of that part. And then you're going to pay 25% of the next little section, and then keeps going up. For those who are way up there, maybe after you get your college degree, that'll be you. Once your income goes over $372,950 taxable, all those deductions have come off, you're paying 35% on any of your income above that amount. Now again, I thought you might be interested in some income tax information, and I hope you all get up to that 35% bracket. But the point is that the piecewise functions are actually very useful in life. It's not that they're there just to be annoying to algebra students. Okay? And that's going to finish our piecewise discussion. So basically, here's what you want to remember to do. You want to remember to kind of break off that graph at those boundary lines. And how do you determine your boundary lines? Well, your boundary lines are determined, here they'd be determined by these income levels. In the case of the telephone example, it was the 450 minutes. And you knew that. Your common sense told you that 450 minutes was the break-off in how you computed that. Now, for these algebra class problems, you can see from the intervals where your cutting points are, all right? In this case, it's -1 and 2. So you might want to just put those on your graph right away, okay? Another suggestion that I've given is to go ahead and plot the entire graph so that you can more easily pick out the piece. And you can either use an eraser and erase parts you don't want. You can physically use scissors and cut them. Whatever will help you be successful. And I'll see you at the next lesson, I hope. Bye.